Hello, everybody, people who is watching this video. I'm recording this because I want to make an explanation about my thesis project. Here I'm using a computer without GPU, graphical processing unit, to install the executable of my user interface prototype and then make some proofs. Okay, so first we are going to install the program. Here we have three different folders. I don't explain this in the thesis because this is extra. This is something extra. But testing is just if you want, if you have the math software installed, you just double click and you can execute the program. Then for redistribution files only, it's the installation. If you have still MATLAB installed in your computer, and if you want to make the whole installation, but just to supervise if the installation is correctly done. Finally, we have for redistribution, and this is interesting because this is the file that every person that doesn't have MATLAB, that doesn't have any idea about programming, about the necessary theory for artificial intelligence and gait biometric recognition can use. So for redistribution, we have my app installer. We have to unzip this. We have to unzip this folder, and I'm going to make the installation for you. Let's see how much time it's going to take. It's going to take a small time. Okay, I'm making this explanation in English because my thesis project should be defended in English, should be disserted in English. So it's a little practice for that. Okay, here we have a README file where you can see a little information about the program. To install the application, load program file, my app installer. Okay, so let's do that. We are going to execute this, and we are going to wait for a little moment to the files be installed for a window that is going to script what we are going to install in this computer. We should remember that this computer is a computer that is average in their computer resources because it doesn't have GPU, and we are going to make an installation here. So I named the program as Gait. I don't need something fancy, so I name it as Gait, and we can see the description. Biometría de la marcha, prototipo. Esta aplicación extrae una firma de la marcha de una secuencia de imágenes correspondientes a la silueta de la marcha de una persona caminando. Almacena las características extraídas en una base de datos, permite entrenar un modelo de clasificación a partir de los perfiles biométricos creados. Finalmente, brinda la posibilidad de identificar personas en base a su marcha mediante una entrada de información correspondiente a una secuencia no vista por el sistema. Isaac Arias Serrano, and here going, you have the contact info, the Hotmail, ESC Arias, hotmail.com. Okay, so next, this is just the whole live installation steps. Next, we see that the program is going to be installed in programs files. So we add the option to a shortcut in the desktop. So this says that you need some files, some functionalities of MATLAB to work. This is not going to install the whole MATLAB environment. It's just going to install the necessary functions to work in the computer. Because in every moment, the installation is going to install what they need for the user interface prototyping and the functions, no MATLAB. So here we click next with the agreement. Everybody say yes. And then here is an explanation of what you need and what is going to be installed. You click on install, and I'm going to recover the recording when this installation ends. Okay, Now we have just finished the installation process, and I download a little data set of from Cassia B. We have here the Cassia B database, just a little sample to show the functionalities of this software. So the installation has finished, and now we just push the button finish. This is ended, and now we have this shortcut to execute our software. So I'm going to make double click here. This was a beautiful logo that I designed for this. Also, this is with a free to use license. So I have no problem, and I name as Biometría de la Marcha Universidad de Investigación Yachay, this user interface prototype. So remember that this is not going to use any GPU. This is for any computer with low resources. So now our software is starting, and now we can see this software is named as Biometría de la Marcha, and we here now have four options. Okay, sorry for the interruption. There was some a noise out of the room. So going back, we here have four options. First one is to insert a biometric profile individually. So we here now have to label the user biometric ID, and we have to pick the sequence. In the second option, we have the function to multiply, to adding in a multiple way the biometric profiles. Then we have two final options, two final functions that are going to be used for any person at the moment that is going to execute the software. And we have entrenar modelo, that is model training. And finally, identificar perfil, that is profile identification. First, if we want to make one of these two functions work, we need to add some biometric profiles. So first, I'm going to make the multiple biometric profile adding. So here, when I click a window, is going to be prompted, and I have to pick the folder where the Cassia B user sequences are recorded. So I choose Cassia B, I choose seleccionar carpeta, and then we have a little prompt that is going to say, pick the number of subjects. Pick the number of subjects that you want to add. We have that in Cassia B, we conduct our investigation until 25 subjects, but here we are not, we are just going to work with 5 subjects. So I pick 5 subjects, I pick OK, and then it says add the number of sequence, because every subject in the normal sequence condition, in the normal sequence state, has 6 sequence. So I'm going to pick 5 because I want to make the demonstration with the sequence to see if it can work correctly in the recognition of people. So pick the number of sequences. I'm going to pick 5 because I want just to pick the 5 sequences out of 6, and pick the camera angle. So I'm going to pick the 90 degrees because, as we can see in the results, this was the angle, the camera angle with the best performance for the model. So I'm going to pick this, and behind this window, our computer is going to be working adding the biometric profiles. And and for instance, here we have this file named as biometric profiles that means that this is our little database for the future extraction characteristics that were extracted by image in the sequence of a subject. So here we have the almacenation, here we have the storage of the gait info. Then we want to make a model of these extracted features. Remember, all the features that were extracted, this image explained in a summary the complete model. this gate sequence was converted by the reported study of Cassia B into a gate silhouette, but here we make a gate signature that then is converted into a future vector. This future vector is labeled for user, for its user for ID, is labeled as an ID for every user, and is storage in the biometric profile database. That's the meaning of that database. Okay, so now we have to train the model, and now we are going to pick the option. And other thing about this user interface prototype is that a little description is going to be made as the moment you point the clicker, you point the pointer in over a function. But if you don't click this, it's not going to work. So here we have a little explanation. We see that this says esta opción permite generar un modelo de clasificación de los perfiles biométricos previamente generados. So now we are going to click this option. And we just have to wait. Because as I said, this process is made behind. We can see it's not necessary to know how this works, but we can use it. And if we read the thesis, we can understand deeply the work of this software. Sorry, my camera is, I don't know, this computer, as I said, is a low resource computer. So that's maybe the reason because the camera glitched. So I click here and I have to wait. I had to wait. This LED is going to change in color when the process ends. So we just have to wait that the different files are generated. So let me see if I can start the camera again. I don't know why this is starting like glitching. So now we just have to wait for a few moments to train the model, because now the computer is training the model. I'm going to turn off the camera again. So now we have to wait for the training phase of the generated database ID profiles. So let's wait for little moments. Maybe I pause the recording to people don't wait a little longer, but I just want to record the whole process in this part that people watch how this work. So just let's wait for a moment. Okay, now we see that this okay, we see the LED changing the color, and now as you can see, the different metrics and additional metrics are created additionally with the confusion matrix file. Let's start the camera again. I don't know if this is going to glitch, but here I want to explain the files that were created. Why? Because we easily can just click the option to train the model, but these additional files are necessary for a better comprehension of the work. Because here we have the trained model. This trained model, that MAT, is the model that simulates the classification, the artificial neural network classification. So every classification, every identification, every recognition that we want to make has to load this model, simulate the future extraction for the sequence that we provide, and then this is going to classify, just needing this file. But here, 3 additional files were created, and now we're going to see what they do. Okay, so metrics. Metrics create the confusion matrix. It's printed in a column way, so we are not going to see more in here. For example, if I want to see the matrix, I have to do something like this. No, it's not possible because it's just a node block. But here we have that the accuracy is printed, and we have an accuracy of 90 to 70% of accuracy. So if we want to see advanced data about this model that was trained, we can click additional metrics. And the additional metrics are going to calculate, are going to deploy the different metrics for every class that was created in our database. So we can see the record for class 1, the precision, the specificity, the F1 score. We are going to see everything for every class. And this is interesting because this can help researchers, this can help users to understand the performance of a given identification model. So now we are going to just close this, and we are going to see the confusion matrix. So the confusion matrix, I don't know why this picture is here, but the confusion matrix displays the results of the class trainings. So we have a validation set, we have a test set, and we have a training set. The validation set is used to simulate, to see the performance of new, never seen data to the classification artificial neural network model. So the classification performance was this. And the metrics, the advanced metrics that we see in this file came from this confusion matrix calculation of metrics. So here we have that the numbers were very accurate. And finally, the most interesting part is going to make an identification from the given profiles. So I pick identificar perfil, and now I'm going to pick one of the proposed sequences. For example, I want to identify the subject number 4. I'm not going to pick the 1 or the 1, 2, 3, 4, or 5 sequence because I provide until the sequence 5 to make the training. I have to provide the sequence number 6 to make an identification because in theory, this sequence has never been seen by our neural network model. So if I pick sequence number C that is unseen for the training, for the validation, or for the test, this is completely new for the neural network classification model. This, in theory, has to make a correct recognition of the person, given that the accuracies were higher. So I'm going to pick the camera angle view of 90 degrees because I trained my model with 90 degrees sequences. So I'm going to pick here, seleccionar carpeta, and the identification is going to be made. So here we have. La clase predicha con mayor probabilidad es 4. Now I'm going to make another identification. For example, subject number 5 and the sequence number 6 for the view of 90 degrees. I pick, I wait for a moment, and la clase predicha con mayor probabilidad es 5. Okay, let's make another identification. For example, subject number 2 and the sequence 6 that was never used for any training, validation, or test, and the 90 degrees view. I pick the sequence and the identification says la clase predicha con mayor probabilidad es 2. So here we have this software is able to identify persons just giving a Gait sequence. And if you have any doubts about how the Gait sequence really sees, let me show, for example, how a sequence works. This is what the model receives, and they extract the characteristics and they train with this. In the case of the identification, they extract the characteristics, but they compare these extracted characteristics with the trained model. So as we can see, this is just an image, but if we see them faster, we can see them as a video. Let me show you. I'm just pushing the the right arrow to pass between images. But if you can see, this can be interpreted as a completely sequence. Let me show you again. And it looks like a video, but no, it's me just passing between images. So remember, we have this image. This image is a Gait silhouette, a Gait signature is extracted, and a future vector is created. Just using this image from a complete sequence. We need a complete sequence. Remember, that's the idea why we provide the folder, not the image. We provide the folder. Let me show you in a final classification example. For example, the subject one, and I'm going to provide the 90-degree sequence. Remember, we are providing the whole sequence, no, not just the image, the whole sequence, because the whole sequence is compared to make the match with other sequences. So we have subject number one. And here is the explanation of my thesis dissertation, my thesis project, sorry, for profile, for gait biometric identification using biometric profiles. So thank you for watching, and I just hope that you can see until the end of this video.